start the recording if you
Yep.
would. There we go.
Yep.
All right, folks. Well, good evening. Thanks everyone for joining the HAMSci SEQP Roundtable. Tonight we want to talk a little bit about the events that we're hosting on April 8th, how ham radio operators can contribute, and some of the experiments we're doing and why we're doing them. What I'd like to do is I've got a brief presentation, maybe about 10 minutes, that both Ed, WX2R, and Nathaniel, W2NAF, will help me on some of the slides. And if it's okay with everybody, I'll share my screen. We'll get right into it. And then we've got a good 20 minutes or so for questions. Anything else before I get started? Otherwise, I'll get going. Nope, great. Hold this up, close some of my controls. Great. Okay, tonight we're going to talk about the HAMSci Festivals of Eclipse Ionospheric Science, where we're looking for contesters, HF operators, shortwave listeners, and citizen science. Real quick, Ed, is my screen shown okay?
Yes. Okay. And your audio is fine as well.
Great, thank you. My name is Gary McKeaton. My call sign is Alpha Foxtrot 8 Alpha. I'm one of the many volunteers on the ham radio side of the equation that helps keep HAMSci moving forward. So a little bit about HAMSci. We're lucky tonight to have Nathaniel W2NAF, who actually started HAMSci in late 2016, early 2017, and is still leading it to this day. So Nathaniel would like to give us a brief background.
Sure, Gary. Yeah, so HAMSci, the Ham Radio Sciences Investigation, we're a group that joins together the amateur radio community and university researchers, and we're trying to do that for mutual benefit. So we want to advance scientific research and understanding through amateur radio activities, encourage the development of new technologies to support this research, and provide educational opportunities for the amateur radio community and the general public. So I got into amateur radio when I was back in high school, and I thought it was really neat. So I eventually got my PhD in ionospheric physics and made a career of this. And now I'm an associate professor over at the University of Scranton, and my call sign is W2NAF. So yeah, HAMSci, we've been around since about 2016, 2017, and we are working to get these professional and amateur communities to work together. I'd also like to thank our sponsors, the National Science Foundation and NASA, for their support in this project.
Great, thanks, Nathaniel. Yes, many times we hear about kids or teenagers or whatever where they get into ham radio and it leads into a career. It happened to me. I'm a retired engineer, and Nathaniel's a great example of one who's gone on to university work, so helping many other students too, and helping a lot of them get licensed too, I would add. Okay, so we're here to talk about the events around the solar eclipse, and unless you've been living under a rock, I know here in Cleveland we're in the path of totality, and about every third news story is either about the eclipse, about the potential traffic jams, or some sort of thing. But we're here to talk about the good stuff, how ham radio and the eclipse are going to work together. One thing I just want to give you guys a hint, if this is a great website put up by NASA. You can there's a URL that's on the side, maybe hard to copy down quickly, but if you search on NASA Eclipse Explorer in your favorite search engine, I'm sure this will come up. It does nice videos of how the eclipse will be moving across the country. And it's also on Eclipse Day, you can follow it live. The other nice feature is you can type your zip code into it. And if you're near the path of totality, it'll tell you how long totality will last and so on and so forth. So that's a nice little tool from the folks at NASA. But if you would, just keep this picture in your mind a moment, because the path of the eclipse will be referenced a couple of times in our discussions. So what does HAMSci do? One of our primary areas of focus is studying the ionosphere. I think most hams realize that the ionosphere is what's responsible for long distance or DX communications, as signals usually on the HF bands between 160 and 10 meters leave our antennas. They go up in a direction and refract off the ionosphere and come back down to the Earth at some point far, far distance. And sometimes if we're lucky, we'll get multiple hops and we can send our signals all the way around the Earth. But the ionosphere, like any other natural phenomena, is ever varying. There's a lot of things we know about it, but there's just as many things we probably don't understand yet. To briefly review how the ionosphere kind of sort of works on a daily basis, at night it generally dissolves into two layers. When the sun is not shining on the upper atmosphere, all the free electrons and things recombine, and we've got a neutral atmosphere. We end up with two layers. During the day, after the sun has done its thing, the extreme UV radiation and X-rays hitting the top of the ionosphere will cause the layers to split. We'll end up with four layers, and each of those layers has a distinct effect on radio wave propagation. F1 and F2 are beneficial, and the D layer is usually not beneficial because it causes signals to be absorbed before they can be retransmitted. But enough of those details. A couple of interesting points about the ionosphere is that day to night transition. Many of you have probably heard about gray line propagation, where it seems that like at sunlight, or excuse me, at sunset or sunrise, you can get some pretty good DX contacts along the gray line path where the sun is just rising or just setting. And that's something we can study during the eclipse as well. Because during the eclipse, the eclipse, of course, happens during daytime. But for a short period of time, the moon casts a shadow on the earth, and it causes what are basically near nighttime conditions. The nice thing is, from our respect, is that it happens rather quickly. The moon is moving pretty fast. It's moving at supersonic speed. The eclipse, if you're in a path of totality, like here in Cleveland, it only lasts 4 minutes. And that's kind of a nice opportunity to study that transition from day, essentially, to night and back to day again. So that's why we're so interested in the eclipse. So some other questions we'll have around this study. The reason we're doing this is we'd like to know, or like to be able to confirm, that the eclipses will show up in our ability to communicate on HF. Will the 20-meter band, for instance, shorten up like it does at nighttime? Will 40 meters go longer? Will 80 meters and 160 meters wake up in the middle of the day just because the eclipse is passing overhead? If we do observe those effects, how large are they? Are they very subtle and kind of hard to pick out? Or is it very dramatic, like, whoa, the bands have closed down, what happened? Some other interesting points we can decide is how soon before the eclipse do we start to notice these effects? And how long after the eclipse has passed do those effects linger? Those can give us some clues about the things going on in the upper atmosphere. And of course, I mentioned gray line earlier. How similar are the eclipse effects to the normal dawn and dusk transitions? So those are the things we're going to try and study with the data I'm going to talk about generating. So real quickly, let's look back at 2017. This image here, it's nice and colorful. It's called a heat map. It represents the number of contacts being made. It also represents the distance, the average distance of those contacts, and at the horizontal scale is one of time. So the reason it's called a heat map are the colors. These bright, more reddish, brownish red colors, those are considered high energy or high heat, or in our case, a high number of QSOs occurring. So you can see at this time here, about an hour and a half before the eclipse was overhead, this particular point in the US, we had a lot of QSOs. We've got a good dark color here. Most of those QSOs were in the 1,000 to 2,000 kilometer range. Seems pretty reasonable for an August afternoon, which this was in 2017. Between an hour and a half and 1 hour before the eclipse, not much changed. We had the same coloration, the same number of contacts roughly, and about the same distance. But after about that 1 hour point, when we're starting to approach the actual point of totality, these colors are starting to lighten up a little bit. That indicates that fewer QSOs were occurring, especially during this path of 1,000 to 2,000 kilometers. And if we quickly slide over here to the 0 hour, right when the eclipse was right overhead, we've got a lot of light colors here. That means the QSO count had really dropped on 20 meters. And some were shorter and some were longer, but we had far fewer QSOs occurring. About a half hour after the eclipse, you see the colors starting to darken up a little bit. That means the number of QSOs was increasing. again in about the same region, about 1,000 to 2,000 kilometers. And after about an hour to an hour and a half, the band was almost restored to normal. Now I say almost because you can see the coloration here after the eclipse is different than it was before the eclipse. And as I mentioned earlier, one of our science questions is to try to figure out one is to confirm this behavior, that things are really different before and after. And then two is to obviously look into the reasons why that happened. Now, it may take years to come up with some of these answers, but the only way we can get it done is if we got some data that we as hams can contribute. So the mechanism we've set up to help hams understand and contribute to the research is something called the Ham-Sci Festivals of Eclipse Ionospheric Science. And these festivals are a number of different events where we hams can operate really as what we call citizen scientists. As I said earlier, I'm a retired engineer. No way would I consider myself a scientist, but yet by participating in these events and some of the other things Ham-Sci does, I can participate as a citizen scientist, contributing information that the professional scientists, such as Nathaniel and some of his cohorts, can then work on some of these difficult questions. Speaking of citizen science, Ed's pretty well versed on the topic. Ed, would you want to go into that a little more in depth?
Yeah, thanks, Gary. And you said a couple of key words, I guess. First in terms of data, and secondly in terms of just the fact of not all of us are scientists. I'm a media guy. I've did marketing and media for newspapers and television stations for many years. But my interest in this subject really comes from the fact that I've always been interested in radio. I've always been sort of interested in the science and astronomy side of it. And we've done a number of presentations, well over 80, since we first started, talking about these eclipses. And there's been a common theme that have come, it's really come back, from non-scientific hams. How's that for a phrase? The fact that I've always wanted to do this and sort of give back and be part of it. And here's a good chance to do it. And as Nathaniel, I guess, has brilliantly created, Ham-Sci, the sort of citizen science cooperation really goes back well over 100 years. In the literature, sort of going back to the early 1920s, the National Bureau of Standards, thinking back to what radio was and what people knew about it 100 years ago, was very interested in terms of understanding sort of, the backgrounds, the early background of the ionosphere. What causes fading? I guess a question, if you were an SWL when you were a kid, that was one of the first things that you always thought about. Why do signals come and fade? And the NBS asked the fledgling ARRL and Hiram Percy Maxim if he could sort of organize amateurs to study this topic. And Percy Maxim did that. And that sort of became the data underpinning, for a lot of the early work that the National Bureau of Standards used. So we've come full circle 100 years, and the challenges are probably greater today, in terms of understanding the questions, but our ability to gather data is far better today in terms of looking at our capture mechanisms and our ability to get out the word. And that's what Ham-Sci is all about. So Gary, let me turn it back to you and take it from there.
Sure. One point that Ed made that I'd like to expand on a little bit is yes, as hams participating in the events that I'm about to describe, we are giving into science. We are helping science move forward. But Nathaniel will tell you, he and the other scientists are equally as interested in taking their science and producing something that will benefit us as ham radio operators. For instance, better propagation prediction programs. Many times there are places where you can go to websites and plug in things like solar flux, time of day, your location, your antenna type, and sort of whatnot, and receive a prediction. Say, okay, here's the statistical probability of you contacting France on 20 meters tomorrow afternoon. And those predictions are reasonably good, but I think with the proper type of science applied to those models and predictions, we can get that to be much, much better someday. So that's the kind of thing that the science folks can hand us back to ham. So maybe one day, whether if we're still on the air, or our kids or grandkids, if they're licensed and on the air, can someday go to propagation prediction sites with a very high probability of success, maybe 80 or 90%, and figure out to whom they can talk to, when they can do it, and why. So again, we want to make sure it's a two-way street. Well, let's talk about the ham radio involvement. Let's see. So we've got a lot of different events as part of these festivals, and I'm only going to talk about a couple of them today because these are the ones that we all can participate in the next 10 days, or actually on April 8th. And some of these others take a little bit more setup and a lot more time to explain. But anyhow, we'll talk about the Solar Eclipse QSO Party, the Gladstone Signal Spotting Challenge, and the Medium Wave Doppler Experiment to give you a good flavor of what things you might be able to do come April 8th. So the Solar Eclipse QSO Party, probably the easiest to explain. If you've ever operated a contest before or even gotten on during field day, you're familiar with contesting. People get on the air, they contact one another. Contacts are relatively brief. What we're asking is that people exchange a signal report and a 4-character grid square. Now, a lot of different modes can be used. If sideband is your favorite mode, that's great. Get on sideband, call CQSEQP, and work some other stations. I'm a CW operator myself, so that's the mode I'll be on. But also, we've got a lot of people who enjoy FT8 or FT4. Those particular modes are wonderful for collecting data. Get on, make contacts, and if you do operate FT8, please go into the configuration, the setup, make sure you're connected to the internet, and check that little box that says send off your data to PSK Reporter, data collection websites, because that's how you as a ham, all of the interesting receive signals that show up in your left-hand receive window and across your waterfall will then go to those places, those databases like PSK Reporter, and we can use that data weeks, months, and even years from now. But anyhow, back to the contest. Pretty straightforward so far as the scoring. It's the total number of contacts times the number of grid squares you work on each band. All the details for the rules and how to enter and where to send your logs afterwards are available on the HamSci website, hamsci.org/eclipse. There's a lot of guides there, some frequently asked questions. And if you do have a question on something, there's a button where you can shoot us a question as well. One thing we recommend highly is that you keep a log of your contacts while you're operating the SEQP. N1MM is the most popular and the best configured. We learned earlier tonight that N3FJP has a VHF contest module that can be used for the SEQP. It allows you to enter your signal report in grid square, so that's an option. If you're an FT8 person, just use WSJT-X. We can accept your ADIF type log. So a couple more details about the contest. Of course, when is it? April 8th, we know, but what times? It's actually over a 10-hour period, 1400 to 2400 UTC. Now, don't let that put you off. Don't think that we only want people to operate the entire 10-hour period. If you can operate a couple hours in the morning, that's great. A couple hours in the evening, or maybe for a 4-hour chunk in the middle of the day, that's fine. The reason we choose these times is take a look where the eclipse's paths are. It's about 1700 UTC, or about 3 hours after the start of the contest when the eclipse first appears. That means we're going to have about 3 hours of SEQP QSO data in logs and in the databases before the contest. That gives us what we call control data. We can see how the bands are operating before the eclipse gets anywhere near us. And of course, there's the long period during the day, about 3.5 hours, while the eclipse is transiting the US. And about 2.5 hours after it leaves the coast of Maine, that's when the contest will be over. But again, the point is to get on the air, make some QSOs, log it if you possibly can. If you're near the path of the eclipse, by all means, when the eclipse gets close by, get off the radio, go outside, put your solar glasses on and take a look. We're dedicated and devoted to our contest, but eclipses are wonderful natural events. The next one in the continental US will be 20 years from now, so you don't want to miss this one. So yes, please operate, but also make sure you get to enjoy the eclipse and have fun in the process. Now, one other thing I do want to say too about the, before we leave the logging topic is, in October, we had about 220 or so logs submitted after the contest. Those logs contained over 4,600 different call signs. So when you get on the air and make contacts, if you can send in a log, fantastic. That helps us a lot because when you send in your log, you should be telling us exactly where your grid square is. We're going to ask you that. And it helps us identify your station and the data accurately where you're located. But there will be a lot of other people on the air operating. If they send in logs or not, that's still wonderful. The more the merrier, I guess we'd say. The next event I want to talk about is a little different. Some people are familiar with Whisper mode, WSPR. It's a mode that was designed particularly for propagation studies. And it's an interesting contesting mode because it's contesting via one-way signals. You know, most QSOs we think of as two-way. There's a transmitter and a receiver and vice versa. But with this particular mode, somebody is transmitting a whisper signal, usually for 2 minutes, and they go into a 2-minute quiet period, a receiving period. And around the country and around the world, there are other stations who receive them and upload those receptions reports into a database. The end result, many people are familiar with, a map that looks like this, a map of transmitting and receiving stations. Here, this one is a nice representation where the different colors represent different bands. This was probably taken a couple of years ago. I don't believe it was during the contest. It was just an image I snapped from whispernet.org. But this gives you an idea of how these QSOs are recorded, how the data is saved, where we have both transmit and receive locations. We know the time, the frequency, and the band that things were made on, and that's the kind of data that will later on help us do the research. So if you're a whisper enthusiast, even if you're already set up and ready to go, after the contest, come over to the HamSci website, enter a form for entering the contest, and we'll total up your reports and see how you rank with your peers. So now we've talked. Oh, one other thing, just to give you an idea where all this data ends up going. The CW folks particularly will end up on the reverse beacon net, calling CQ contests and that sort of thing. We've talked about Whisper and WhisperNet a little bit, and PSK Reporter mostly collects the FT8 reports. To give you an idea of the scale and the scope of our data, for the October eclipse, we had a total of 300 logs between those two events. Over 7 million spots were recorded. So that's a lot of big data for the scientists and mathematicians to chew through, but that's what they love to do. So the more the merrier. So we've talked about contesting with two-way QSOs, one-way signals, and now we're going to talk about a purely receiving event. Many folks started out in ham radio like I did by doing either shortwave or medium wave listening, and many people still enjoy those activities. So we've actually got an event that's built entirely around reception of medium wave broadcast stations. I think the best way to explain it is to show the example of one particular station, what he did during the event, and let me jump right into that. So in October, Richard, KE6EE, who lives in Central Northern California, did some reception recordings of the AM band. And you'll see that he received, in particular, he was focused on receiving 3 stations, 2 of which were on the other side of the eclipse path from him, and 1 of which was closer by, but not directly impacted by the eclipse. This was a great setup from a scientific point of view because we had we expected eclipse effects up here, and we weren't sure what to expect down here, but that's part of the fun. So to jump right into the results of what Richard saw, we can take a look at October 13th, the day before the eclipse, considered a normal day. This part of the day at nighttime, the signal was dropping off a little bit as the sun was coming east to west. And then once the sun rose, the AM signals declined during the day. Not a surprise. Most all of us have experienced that, I'm sure. But when the eclipse happened on August 14th, it was quite a bit more interesting. The nighttime and sunrise effects look pretty similar. But look what happened when the eclipse started getting nearby. The signal strength increased quite high. And then it started to dip before the eclipse completely ended. So you can see there's a great difference between these two graphs, a great difference impact the eclipse had on the medium wave signals. And we like to see more stations record more stations and see if these effects hold true again in the April eclipse. So that was just, like I say, 3 of our events. I tried to sum up a little bit. Hopefully you'll find 1 of those 3 interesting, or maybe 2. We've got some folks who'll be having a whisper transmitter on an antenna on one side of their property and operating the SEQP in another. So mix or match, do whatever you'd like. Again, the information is all available at hamsci.org/eclipse. And I think now is probably a good time to open it to the floor and let folks ask some questions. If you want to unmute yourself and ask that way, the other good way is to use the chat feature at the bottom of Zoom. There's a little button that says chat, and you can put your question in there and we'll go through them. Let me open up my chat window and see if anything's coming through. Great. So any questions on WSPR, the Gladstone Signal Chat? Do we have any whisper operators here today? Maybe we do, maybe we don't. Maybe not.
Let's see here. There we go. Yeah, just one quick question on the whisper side of things, and it's just background information. Do you need data a day before or preferably both before and after the day of the eclipse? That's easy to do on Whisper, but maybe you already have enough data.
Well, I don't know I've ever heard anybody say in this group they have enough data. But yes, a few days before and a few days after is very welcome. Because aside from the eclipse, which we're all planning for and know is going to happen, a lot of other things happen between the sun and the earth. Obviously, we're in cycle 25. The sun is very active. And there are some other interesting things that may happen during that those few days. So the more days that we have data for, the better.
Thank you.
See this comment from Scott.
Okay. IQ recordings. I've not ever had a software-defined radio in my shack. I've not made IQ recordings myself. But if I can put my friend Nick Hall-Patch on the spot for a moment, I know Nick has some experience doing these IQ type recordings. Nick, is there any advice you could offer?
It's basically, first of all, am I coming through? Yeah, I think
Yes.
so. Okay, good. Okay. I was immediately going to ask you what receiver we were talking about. Yes, it's IQ recordings. If you're using KA9Q, and this is something that I didn't know about until the workshop this past weekend, then it's a different format from what I've been used to. The primary concern, what sort of band are you, what sort of band are you listening to? Are you listening to medium wave? Scott? Okay. Oh, sorry, 0 to 30, you're doing the big recording. Okay. Yeah, the main concern is that you're not overloading. Like that's a big inhalation of signals there. And you don't want to be generating a pile of basically spurious signals. So you have no idea whether the eclipse is affecting something or not. So in the days leading up to the eclipse, learn what's real on that recording is the best advice I can give. Sort of put attenuation there and just keep, sort of letting more signal in until you can see that there's obviously odd things starting to happen, and then crank back again. Your assumption is correct. IQ data is what you want. Okay. 10 dB probably is not going to be, not going to be a big problem. It'll certainly help you on the shortwave because the strong signals are on medium wave. The main thing is that you don't want to overload. You're going to be trying to lock it to GPS DO. The other thing is with your computer clock, and you probably do this already, but you want to be using some form of network time protocol or something like that, or really set that clock accurately. Excellent. So yeah, NTP, excellent. Okay. I think that if you look at the medium wave recording page in the Hamsai Eclipse pages, it gives you quite a lot of background as to what's the best approach to take in order to produce good scientific data, and that will apply to frequencies above like 1.7 megahertz as well. I think, is that pretty much answered your questions there? Okay.
Yeah, that's one of the challenges with the IQ recordings of huge sections of the spectrum. One, of course, is the files get very large, but it gets we don't have a lot of participants doing that. So though the data set on an individual basis is very large, we don't have a large community of those files to work with. Nick and his group are focusing on the medium wave bands, and that helps us get sort of a concentration of data in a specific part of the band. Myself, I would prefer to see reception on a more standard mode such as Whisper or something like that, because that data is then shared and with many other hams and created by many other hams, and it just adds to the overall. But the IQ recordings are interesting. Let's see what else we got in here, Ed.
Yeah, there's a couple other comments. We have a comment from Dave, KJ5FFF. Congratulations, Dave, as having a new ham and anything that he can do. So,
well, the thing I would do is I'll put up a couple of screens when we're done that talks about some of our Hamsci activities, different Google groups that we've got going, and some various Zoom calls we have during the week. And you're welcome to participate in all those communication channels to learn a little bit more about what we do. Another suggestion is recently the ARRL published a good book on radio wave propagation. And to peruse those chapters, it's what I call beginner friendly. It's not real scientific, and I think you could learn a lot from a book like that. And it would also raise some questions in your mind, and then you could bring those questions to a group like us, and we can help you work through them.
yeah, perfect. So, just a couple of other comments that came up in the other meeting. One was about POTA activations. Okay, yes, indeed, POTA activations are welcome. Okay, in terms of putting signals into the ionosphere, and also perhaps cross-referencing your logs with what you're submitting to POTA and also to the SEQP. One thing that triggered a memory after the meeting was that hamcation. We learned that both Florida and I believe Georgia are actually doing POTA weekends on the 6th and 7th prior to the eclipse, activating as many parks as they can. And the suggestion is that perhaps not as a POTA event, but as an event just to continue the weekend, is to activate on April 8th, regarding the QSO party. And there were some comments in the earlier meeting about that they think that there'll be a lot of people on the air and a lot of activations, not only because of the fact that it's a good day to operate, but it's also the solar eclipse QSO party. The other comment that came up in the other meeting was that if you are on or near the center line, we would be very, very interested in talking to you about the time delay or time difference of arrival event that Steve Serwin, one of our scientists, is working on. So if you are on or near the center line, if you can drop me a note, wx2r@arrl.net, wx2r@arrl.net. I will follow with you and have Steve Serwin, who's our principal experimenter scientist on this, will follow with you if you can possibly help, because you're particularly in the point of darkness. So anyway, Gary, back over to you.
Okay, very good, Ed. It's good information. A couple other questions. Dennis, W1UE, asked about preferred frequencies for Whisper. And what I've told other people in the past is use the bands where you put out the best signal, because that way you'll generate the most reception reports. And on this particular event, we're not focusing on one end of the band, like, say just 10 and 15, or maybe 160 and 80. The data we collect on any band will be of interest to us. So you do what you feel is you're most comfortable with, what you think you've got good antennas for, and we'll be very grateful for the data, no matter which of the bands between 60 and 10 it appears on. Good, good. All right. One other question that's come up in the past too, occasionally, some folks like to contest and stuff and operate as mobiles. That's one of the few things we don't recommend for the Solar Eclipse QSO party is operating as a mobile. Because then we just simply have too many things in motion. You know, of course, the Earth is spinning, the sun is moving, the moon is moving between the two, and then you're moving as well. We get so many variables in there, it kind of makes it very difficult to interpret the data. So we prefer people stay put, or if you want to operate a POTA site at one park in the morning and then pick up sticks and move to another POTA site in the afternoon, that's fine. If you do that, please send us 2 different logs, each one with your proper grid square in it, because an important part of our data is knowing the geographic location of all the transmitters and receivers, and collecting logs is one way in which we do that. And by the way, we accept logs in both Cabrillo format, which is typical for contests, but also the ADIF format, and that's a very common format that I think every single major logging program they can produce. So hopefully one way or the other, we can import your data and then give you credit for your contacts when we write up the results some months from now.
But if you don't send in a log, I think the most important thing is to get on the air that day. You know, as many people as we can, really sort of propagate and populate the ionosphere that day. I think is really what matters. Okay. You know, we were, I guess, quote unquote, lucky, I guess, with the October annular, is that it occurred on a Saturday and there were some QSO parties around us. But the Solar Eclipse QSO party is on a Monday. You know, and millions of years ago, we tried to negotiate with the moon to move it to a weekend, but it didn't necessarily work. So, you know, we're on a Monday and we need as many operators on the air as we possibly can. And obviously, I think, you know, those who have, you know, participated in our meetings and have written us emails, and obviously people like yourself, I think will be participants. But obviously, you know, tell your friends, tell your clubs, okay, and get on the air, you know, for this sort of once in, for many of us, our lifetimes events. You know, obviously, as Gary pointed out, this is the last eclipse, total eclipse in North America for 20 years. So it's a good chance for science. Do it for science, do it for yourself, and do it for us as well, too. So Gary, back to you.
Okay, good. I'm going to grab the screen share a little bit. One little bit of a commercial here at the end for HamSci. Let me flip back over to Zoom. No, I don't want that. That's what I want. So just be aware if this kind of thing is interesting to you, HamSci, we now have over 1,000 members. Membership is not a big deal. You simply go to our Google group, sign in with your email address and create a password and you're in. There's nothing, no secret handshakes or any of that sort of thing involved. But you basically go to the HamSci homepage, and one of the first things you'll see at the front is the button for joining HamSci. From communications, we're very open. We're big on communications. We have a number of great calls during the week, Monday evening, Thursday morning, and Thursday afternoon, where we discuss some of the technologies we're designing to enable this science. Some of these technologies are actually very simple and inexpensive and easy to build on your own workbenches in your basements or wherever. And then we've been talking about the SEQP and those sorts of events on our third call. But the other thing that I think is important to mention too is to realize that we're all volunteers, or most of us are volunteers. We don't have any source of income. We're not a nonprofit. We don't sell anything. But we do have funding from various granting organizations such as the National Science Foundation and our friends at NASA. NASA has a huge citizen science program encompassing many different projects around the U.S. and the world, and we're just one of those. We've also had a lot of support from places like ARDC. We've partnered with the ARL and so on and so forth. So we're a big group. We're growing, and we'd like to have you guys grow with us. So thank you very much for listening. I'll stop again and make sure there's no more questions. If not, we'll call it a night and look forward to seeing everybody on the air come April 8th. All good?
Who wants the final word?
SEQP for me.
Oh.
All good questions. Thanks, everyone. Be well, and we'll see you on the air in about 10 days.
73s.
73.
73, everyone.